Welcome and study with Tanzania Institute of Education.
Irreversible reactions takes place in a forward direction and go on to completion. Such reactions continue to take place until at least one reactant is used up and there is no possibility of changing the products back to reactants. The aim of the experiment is to investigate the irreversible chemical reaction by reacting zinc granules with dilute hydrochloric acid. Requirements: apparatus, test tube holder, test tubes, measuring cylinder, small beaker, spatula, watch glass, and volumetric flask. Chemicals: zinc granules and 2 molar hydrochloric acid. Procedure: take zinc granules and put it in a test tube. Measure about 3 ml of hydrochloric acid. Put it in a test tube containing zinc granules and observe the changes. Shake it well and place the thumb so that if there is evolution of gas, it won't get out. Take another test tube and invert it to this tube which contains hydrochloric acid and zinc granules so that you collect the gas which is being involved. Make sure you don't allow any gas to get out of the tube. Press it well and wait for some time. While doing this, have a burning wooden sprint so that you can be able to test the gas which is coming out. The gas evolved which burns with a pop sound is hydrogen gas. At the end of this reaction, the clear solution will be observed in this way. The reaction is described by using this equation whereby zinc combines with hydrochloric acid to form zinc chloride and hydrogen gas. The reaction between zinc granules and dilute hydrochloric acid demonstrates a chemical reaction which is irreversible. There are chemical reactions in which direction of chemical change can be easily reversed by changing conditions under which the reaction is taking place. The aim of this experiment is to investigate the reversible reactions by using hydrated copper 2 sulfate, and potassium chromate solution. Requirements: apparatus, mortar and pestle, conical flask, measuring cylinders, beaker, test tube connected with delivery tube retort stand, heat source. Chemicals: hydrated copper sulfate, potassium chromate, distilled water, 2 molar hydrochloric acid. Take a little amount of copper sulfate and place it to hard glass test tube. Then stopper the test tube. And tie it to the retort stand. Take a test tube and immerse it in a cold water. Then immerse the delivery tube to the test tube which has been immersed in cold water. Then introduce the heat source to the salt, that is copper sulfate. Heat the salt gently and observe the changes. The color of this salt is blue, so just observe what will happen. In the test tube there is water vapor which is coming out. Before, the salt was blue in color. Now here there is residue of white color. Before, we had a dry test tube. Then let us see what happens with this test tube. You can see there is water. Then take residue the residue remained is white. Take a test tube which contains water which was collected from the salt, then add to this test tube. Observe the changes. The blue color has been regained. Hydrated copper sulfate decomposed to produce copper sulfate, which was white in color, and water molecules. Again, these molecules of water, once combined again with copper sulfate, hydrated copper sulfate is formed, which is blue in color. Also, reversible reaction can be demonstrated by using potassium chromate solution. Take 5 ml of potassium chromate and pour it to the conical flask. Observe the color of potassium chromate. The color is yellow. Take 2 ml of 2 molar hydrochloric acid and add it to chromate solution. You can see the color of the solution is orange. Add distilled water to this solution until the yellow color of solution is regained. The yellow color has been regained. This shows that chromate ions are oxidized to dichromate ions by the addition of acid, while dichromate ions are reduced to chromate ions by the addition of distilled water. The color of chromate ions is yellow and the color of dichromate is orange. Some reactions proceed in both ways. In this experiment, reactants changed to products and products reversed back to reactants.